right, let's start class. So in the last class, I taught inverse functions. So I needed to do a couple of problems before we move on to the next section. The first problem is a homework problem number 19. Okay, so this is a question. Whoa, it's too loud. So if f of x equals x plus square x, find the inverse of this function. Okay, so you don't need to prove the inverse exists for this problem, but you have to understand what does it mean the inverse. Okay, if you can, if you can set this equation, you can, if you're able to solve for x, then the x will be the inverse. The value of x will be the inverse. The value of the inverse at 6. Okay. Okay. So that's a key point. So all you have to do is just solve this equation. Solve this equation. Now, this is a quadratic equation. Okay. Why? If you let u to be square x, then u squared plus u equals 6, right? That becomes a quadratic equation. Then use a quadratic, then you use a quadratic formula to find u, or you can fact it. I think you can fact it. U plus 3, u minus 2, it's going to be 0. Right? Right, so you will get two solutions first. But I think the first one is not going to be a solution. Why? So u is going to be square x, so u never be negative. It's always greater than or equal to 0. Okay? So that's why square x is going to be positive, so it's going to be 2. Okay? So this implies x equals 2. Okay. In other words, h2 is going to be 6, right? h of 2. So if the inverse exists, 2 is going to be the value of the inverse function at 6. Okay? If the inverse exists. Okay. Yes. Oh, it's x equals 4. You're right. That's my mistake. Yeah, x equals 4. Yeah, 2 squared is 4. Okay. So, so my question is, does this function has the inverse? Okay, how to prove that? You have to make sure this function is increasing or decreasing function. I think it's the increasing function. The reason is, you look at this function, right? And the x cannot be negative, right? Clearly. So when x increases, each term increases, they just add them together. It's not like x minus square x, it's x plus square x. So both are increasing, of course, add them together, it is the increasing function. So clearly, it is, I show that clearly h is increasing. You can find the derivative again. So the inverse exists. Okay, you don't need to prove that. It's given, for this particular problem, but you needed to know how to prove this, why the inverse exists. Okay. So the next problem is problem number 39. So f of x is going to be 3x cubed 3x cubed plus 4x squared plus 6x plus 5. Okay, find what's going on here? Find the derivative of the inverse function as 5. How to do this problem? You needed to, you cannot find the formula for the inverse function. You cannot find it. So you have to do is to use a formula. Okay, write down the formula first, so we know what you're going to do. Okay, so clearly from this formula, you have to find the value of the inverse function at 5. You have to find the derivative of the original function. That's easy to find out. Okay, so it's 2 steps. So first, let's find the derivative. It's going to be 9x squared plus 12x plus 6 plus 8. Yeah. Plus 6. Okay. I find the derivative. I also have to find the value of the inverse function at 5. But I observe that f0 is going to be 5. Okay. Why? Because when you plug 0 for x, you get 5. So this implies, okay, this implies 0 equals the value of inverse function 5. That's good, right? Then you can get f prime here, and you know the value of the inverse function 5, so it's going to be f0. Okay, so then you plug 0 for x into the derivative, you get 1/6. Okay, so that's the problem. Okay. So those are 2 problems discussed here. Now the next section is about exponential function. Maybe you learned exponential and logarithmic function when you were in high school, but we're going to have a quick review on this. But our focus is to find the derivative, right? How to find the derivative? Yeah. So definition. So first of all, let's understand the exponential function. Okay. This is section 6.2. We have to define how to define a to the power this when the number is a rational number. Right? If it is just a to the power n is integer here. Okay, m is integer. This is defined to be a times a times a. You have m eighth, right? So ai, m and I integers. Okay. So that's easy to understand. So now, can I define 1 of n? A to the 1 of m. This in general is not defined, but you have to make sure a, yeah, sometimes it depends. Okay, a is positive or negative, depends. If a is negative, this is only defined for odd n. Okay. So this is a defined. This is defined for any value of a if n is odd. Okay, that's only defined for positive or non-negative. It's only defined for, not defined only for only non-negative a if n is even. Okay. Okay, it is going to be the number such that it is n's power equals, yeah, a1 over n is going to be the x such that the n's power equals a. Okay, and this x should be the same sign of a, because sometimes that equation gives you two solutions. X, a have the same sign. Okay. Okay, why I have to say that? Because when n is even, you know, x squared, for example, equals 2, then you have to get plus minus 2. So you have to choose the positive 2. Okay. For example, 2 squared equals 4, right? So 4 to the 1/2 is a number, it's 2, not a negative 2. Now, you also have a negative 2 squared equals 4. But the 4 to the 1/2 is going to be 2, not negative 2. Because I have to choose the same sign, right? Okay. So now, a to the m over n is defined to be a to the 1 over n first, then you put n, okay? That's the definition. So you can define, if the power irrational number, the denominator is odd, then this is defined for any a, but any value a. But if n is even, then it's you have to assume a is positive. So 3 to the negative 3 to the 2 over 3 is defined, right? But the negative 3 to the 3 over 2 is not defined. It's undefined. There's a difference here. Be careful. Why? Because negative 3 to the 3 over 2. First of all, you have to make sure this is a. First of all, you have to make sure this is a defined. Then you cube it, right? So square root of negative 3 is not going to define, so that's why it's not defined. It's undefined. Is something wrong with my pen. Okay, it is undefined. So from now on, we will only consider positive. So otherwise, we have a trouble to talk about. So f of x, a to the power x, we only consider a positive. We will consider only positive rates, okay? And actually we want to consider a is not going to be 1 because otherwise it's trivial. 1 to the any power x's. So this is a exponential function. And then you will ask, well, x is arbitrary number. but you only have, I so far only gave you the definition of the exponential function from a to the x for rational numbers, right? If x is non-irrational number, then you just take the limit, okay? If x is a irrational, okay, number, then a to the x is going to be the limit as n approaches infinity. You take a sequence of n, okay, where xn are a rational number, okay, and approaching x, okay. So a to the line, that's the so now a to the x is defined for nx. It's harder to understand, yeah. But most of the time, with the number we see is the irrational numbers, okay. So we needed to understand this function, right? And so square root 2 to the pi is defined now. Okay, why? Because, well, square root 2 is a number, right? It's positive, not equal to 0. It's not equal to 1. Pi is irrational number, but you can have a sequence of irrational numbers approach that, okay? So it's defined. And let's take a look at the graph. The graph of the function depends on the value of a. If a is greater than 1, this is graph of a to the x. If a is greater than 1. Now, it's interesting to see that a to the power 0 is always equal to 1, okay? You can see that a equals power 0. And a to the 1 is 1, is a, right? So that means this is always 1. And this will be, here's 1, this will be 1 and a. Okay. So a is greater than 1, it's increasing function. Now, if a is less than 1, between 0 and 1, it's decreasing function. It's going down like that. So it's still 1, but this point will be 1 and a. So if a is less than 1, it's smaller than 1. That's why the point is below 1, right? So this is a y equals a to the x, and a is positive and less than 1. Okay. So those are two graphs of the we call the exponential function. All right. So when you see that, okay, you look at, x can be negative, right? Look at the picture here. When I say x is defined for x, I have another mention for the negative x. So we set, when x is negative, you see, when I talking about at the very beginning, when I was talking about a to the rational numbers, those are the positive rational numbers. Okay, I needed to add the 1 things. So go back, okay? So this is defined to be like that, right? So that means mn are positive numbers. So what happens if it's negative? Negative is defined to be this. Okay. Here mn are positive integers. So for mn positive integers, okay, you will get, you can define this first one, a to the mln, but when it's negative, you have to define this to be 1 over this. Okay. All right, so now, so it's defined for any x. Okay. We do have some formulas to, we have some formulas we needed for the further study. Okay. So the first formula is a to the alpha plus beta is going to be go other way around. Okay, so then the next formula is a to the alpha. This is the same as it's going to be a to the negative beta, right? It's going to be a to the alpha minus beta. Okay. I think the third formula will be just a to the alpha and to the beta. It's going to be a to the alpha times the beta. Okay. Then AB to the alpha is going to be a to the alpha, b to the alpha. That's it. So those are the formulas we need. Now, in calculus, what is the next step? We want to know what is the derivative of the exponential function. Okay. So question is, what is the derivative of this function? Okay. We're curious about it, right? When we have x squared, when the derivative is 2 times x, right? But this is not a polynomial. It's not a power function. It's an exponential function, right? So if you don't, suppose you are the first person, right, study calculus, you need to define the, figure out, what is the derivative a to the x, right? The only way you can do at the very beginning, you don't have as a formulas, is to use a definition, okay? So the derivative of this is supposed to be h approaches 0, x a to the x plus h minus a to the x, right? So I have to find this limit. Okay. I modify this limit. I don't know how to write. So I get a to the x plus x is a to the x and a to the h minus a to the x. I'm surprised I can take the a to the x out. Okay, a to the x out. So it'll be a to the x if I can find this limit. This is separate, right? If I can find this limit, the second part, then I'm done. I can take this out, right? I can take a to the x out. So this limit has no x there. Good. Only depends on a. Okay. And what is the limit of that? We have no idea. What is that limit? Right. So I'm going to that's where you do research. Okay, I'm going to let L of A depends on A, right? So LA denote this limit. Because I know it depends on A, right? Then the derivative of that function, oops, is going to be A to the X n times L of A. Right? So the derivative of A to the X is its original function times something depends on A. That's it. So what is that? We don't know. But at least I know when A equals 1, that's going to be 0. Okay? That's obvious. Yeah, this L of A is defined for positive A. Right? And actually, you can show that in further study can show that this is the increasing function. Is increasing. Okay? And from negative infinity to positive infinity. Okay? It can be very large, it can be very negative, small number. It can be negative. Okay. Okay. So it's increasing. So you already started the unit, right? So y can be negative. And when a is smaller than 1, it's negative, okay? When a is smaller than 1, a to the x is smaller than 1. So that's why it's going to be negative, okay? More precisely, a to the 1 is negative for negative a, for a between 0 and 1, L of a greater than 0 for a greater than 1, okay? Yeah, the value increasing from negative infinity, but a is between this a is the only values between a and the infinity, okay? So, we're only talking about a positive a. All right, but that's good enough. I'm going to introduce a number, okay? Definition. E is a number, is a positive number, okay? Such that L of E equals 1. Can we do that? Yes. Okay. Because L of A increases from, you see, for this L, right? When A learns from 0 to infinity, L of A learns from negative to positive infinity. So it will be 1. That particular number should be, E should be greater than 1. Right? I know that E is greater than 1. I don't know exact value, but I know there is a mystery number there. Okay, that number is good. Then then we have the following formula. The derivative of e to the number is going to be e to the number times L of e, which is just e to the x. Okay. So in this world, there is a function, only one function, whose derivative is going to be itself. Okay. So we find such function, the derivative itself. In most time, when you differentiate functions, the function change. But it cannot be the same one. So in this world, there is only one function whose derivative is going to be 1, going to itself. Okay. So now, yeah, this number e, where it's from? It is from this function. In other words, e is going to be the inverse value of 1. for that mystery function. Okay. We can estimate this number, E. It's about 2.78. Right. So now I'm going to try and understand this graph. The graph of the E is going to, because E is greater than 1, so it's increasing function, y equals e to the x. Okay. This is a 1. Okay. But remember, the derivative of e to the x is going to be e to the x. So the slope at every point is going to be the height of that point, in other words. Yeah. Okay, this E is very special number, okay? So we still have lots of other formulas for the E, you know, but I know okay, let's take a look at, so this E is a special number, and e to the x is a special exponential function. Right. Let's look at an equation, e to the kx. K is constant, okay? It is constant. All right, so now, we have to find out the derivative of y with respect to x. Okay. Well, this is just for zeta of two functions. So you can differentiate, how to do that? Use a chain rule, right? So that you can write down directly because derivative e to the u, right? It's given kx, but don't forget to differentiate this with respect to x, so which is k. So k times e to the kx. Now, more precisely, you can write e to the u, and u equals kx. Okay, that's a chain rule. Okay, so dy over dx is going to be dy over du and du over dx. Okay, and that's e to the u, right? Y is equal to e to the u. Then du, u is going to be kx. Okay, that's a chain rule. Then the derivative of e to u with respect to u is going to be itself. Then the second part, it's annoying. Then the second part, there's something wrong with my pen or something. I don't know. Okay. I need to fix it. All right. All right. So it's going to be e to the kx times k. Okay, let's look at the next problem. The exponential function is so special. It's a derivative is going to be itself. That means when we're talking about exponential growth, it grows really fast. Okay, the growth rate, the growth, the derivative, the slope of is going to be the value of the function. Okay. Let's find the equation of the tangent line to the graph of the function, and to the graph of this equation here, x e to the y plus y e to the x equals 1, and this is going to be the point 0 and 1. Yeah, this is indeed a point on the graph. Okay, when x equals 0, y equals 1, yeah, you get. So this is a point on the graph. It's implicit. It is implicit. You know, you have to find it using implicit differentiation. Okay. So what I have to do is, all I have to do is find the slope. Okay. The slope of the tangent line is going to be dy of dx. Okay. When x equals 0, y equals 1. I'm not able to solve for y in terms of x. So you have to use the implicit differentiation method to find the derivative. Okay. So you differentiate both sides. With respect to x, be careful, you know, which derivative we're talking about. So each term right now is a product of two functions. Okay, so you have to apply the product rule. The derivative of x with respect to x is going to be 1. The derivative, you copy the second term. Then you copy the first term, the derivative e to the y with respect to x, you have to write like this, as a general. Similarly, yeah, this gives two numbers, give two terms, yeah, gives two terms. Similarly, you use a product rule to get two terms, and the y and the e to the x, that's it, yeah. The derivative of e to the x is self. All right, so now you can find the general formula for the derivative y with respect to x. Maybe it's not necessary to that because you really needed to just find the slope. You don't need to find the general formula for the derivative. So you can say that at x equals 0, y equals 1. You plug 0 for x and the 1 for y, you get e to the y plus 0, right? Because x 0, 0 times anything 0. And plus the derivative right now is the slope, e to the 0. And y is going to be 1. And e to the 0 is also 1. So there is only one slope left here. So it's 1 plus e plus m equals 0, m equals -1 plus e. Okay, you find the value of the slope, then you get the equation. Okay, the equation will be y minus 1 equals slope -1 plus e, and here's x minus 0. All right. Yeah, the chord point slope form, right? If you know the point, you know the slope, you get equation for the line. We need we just needed the formula for the derivative e to the x. So we can have a larger class of functions we can study. Okay, but the problems will be the same problem, like similar problems in Math 160, 65. Okay, for example, like how to find the maximum value of the following function. Usually we try to avoid the exponential function. Now we can also consider exponential function. Find the absolute minimum value of the function. Okay. So what is the function? The function is e to the x of x. X is greater than 0. But why this function has an absolute minimum value? First of all, we see that f(x) is positive, right? It's above the graph is above the x-axis. Second, I really needed to know when x approaches 0, what happens to f of x. When x approaches 0, the numerator approaches e to the 0, which is 1. The denominator approaches 0. So 1 over 0 should be infinity, but this is going to be positive infinity, right? Yeah, okay. Because e to the x of x approaches 1, e to the 0, 0 from positive side, which is infinite, right? Yes. Okay. All right, the third point, this is going to be also infinite. Why? E to the x of x. E to the x grows much faster than x, so the quotient will be infinite. You know, if you study, I don't know whether it's this L'Hopital's rule, right? I'm not sure it's covered in this section. I'm confused. I'm teaching 2 courses. Yeah. So how to find the limit of e to the x of x? Just accept it. This is going to be, it's e to the x grows faster than x. Okay, exponential grows. So when you draw the graph, is this how does the graph look like? Right. So this is the graph looks like that, right? Then then you see that it must have absolute minimum value. So where it occurs? Critical number. So you have to just find a critical number, okay? So somewhere that's derivative. I guess it's the pen problem. Okay. I'm trying different pen later. So let's find the derivative. According to the quotient rule, it's going to be x squared. The derivative of e to the x times x minus the derivative denominator times e to the x, right? So you will get e to the x times x minus e to the x squared. Okay. So you can take them e to the x out. If you set this to be 0, then what happens? X must be equal to 1. So this is the only critical number you're going to get, right? Right, so the absolute minimum value must occur there. The absolute minimum value is going to be F1. It's going to be, this is going to be E to the 1 divided by 1, which is just E. Okay? So this is where we find the minimal, absolute minimum value. All right, let's do one more problem for this optimization. All right. So the next one, we are given the function xe to the x over 2 on the interval from -3 to +3. Okay? Find the absolute maximum value, absolute minimum value. And the minimum value. Oops, I guess it's not a pen problem, it's a computer problem. All right. All right. So you have to do it, just find the derivative and find the critical numbers. Then you look at the value of the functions at the end point and at the critical numbers. Then you compare which one is right, right? That's the idea. No, this is review math 165. The only difference here is the function is different. Right, all you have to do is find the critical numbers and then evaluate the function and the point of the critical number. The critical numbers. So let's find it's a product rule, right? It's 1 times e to the x and plus x. And e to the, when you differentiate this original function times 1/2. Yeah, this is a derivative of the function e to the half of x. Okay, this is the e to the half of x prime. Right. So let's solve it. It is going to be 1 plus half of x right? If you set this to be 0, the first factor must be 0. So 1 plus x is going to be 0, right? Okay. So x is going to be -2, which is still in the interval from -3 to 1. All right, so there's one critical number in the interval. Then next step is just evaluate the function to at the 2 endpoints at the critical number. So f -3 is going to be negative 3e to the -3 over 2. F of the -2 is going to be -2e to the -2 over 2 is -1. And f 1 is going to be 1 times e to the 1/2. Among those three numbers, there's only one positive. So that means this is absolute maximum value. But we cannot figure out the first two. Which one is large? Okay. So you have to find a way to compare. Okay. Let's take a look at 3 over e to the 3 over 2, right? And this one is going to be 2 over e. Which one is large? Compare, right? Yeah, minus or greater, you know. It's not clear. So what I'm going to do is just consider the quotient. Okay, I consider the quotient. So here's a 3, yeah, e to the negative 3 over 2 divided by 2, e to the negative 1. Okay, I'm going to consider that. Okay. So after simplified, it will be, if I move this down here, this is e to the 1/2, right? Here's 3 over 2. Oops, 3 over 2. Then which number is large? You can even square it because you don't like square, you know. You can use the estimate, right? You can look at the square, and this is going to be 1.5 square. That's going to be e, right? E is a 2.7. 1.5 square is less than 2.78. So this should be easily to figure out. Okay. So that means the one on the left-hand side is less than the one on the right-hand side. Okay. But the value of a negative 3 is going to be negative. It's going to be negative of 3e to the 3 over 2. So this should be great than, right? Which is f of negative 2. Right? So f of negative 2 is going to be the absolute minimum value. Okay. F negative 2. Yeah, is absolute minimum value. Right. So this is about the applications of the derivative of the function. Since the derivative of this function is going to be itself, so the integral of this function is going to be e to the x plus constant c, right? Right. So there are a bunch of problems here you have to look at the integral. Right. For example, integral from 0 to 2 and that is e to x. Right. This is the denominator never be 0, so don't worry about it. Right. How can I evaluate this integral? Well, this integral, you have to define as an indefinite integral, right? This is going to be written in the form e to the negative x dx. Okay. So you have to use a substitution. Okay. Then du equals negative dx. So the above integral is going to be e to the u, right? And the negative dx, dx is going to be negative du. So you end up with an integral like the above one. So for this one, it's going to be negative, right? E to the u plus constant. Doesn't matter, plus minus. Okay, so u is going to be negative x. So we get this. Okay, this is the antiderivative. So the definite integral is going to be negative e to the negative x. Evaluate at the end point. Okay, so it's going to be negative e to the negative 2 minus, that's a plus e to the 0, which is going to be positive number. It's 1 minus 1 over e squared. It's positive number, okay? Double check that at the end, this is going to be, why it's positive? Because 1 over e to the x is positive. There'll be another one. It's integral from 0 to 1. Oops. Right, this is problem 94. So now how do we do that? So you have to use a substitution to simplify, right? One natural substitution is let u to be let u to be 1 plus e to the negative x. There are a couple ways choice, right? Another one is you still keep the radical. Let's try a different one, okay? So we're going to evaluate the integral to find the antiderivative of this integral. So you have to simplify it. So there are a couple of choices, right? So one is you're trying to let u to be e to the x, right? Or e to the 1 plus e to the x. It's in the denominator. I'm going to try this, e to the x or e to the negative x. Right. Or e to the 1 plus, u is going to be 1 plus e to the negative x, or u is going to be e to the x. Okay, there are several options. Let's try. If it's not working, we can try different, right? So let's look at this. Try this first. Okay. Then du is going to be differential that e to the negative x and dx. Right? Not too bad. So that means it's going to be negative dx e to the x. Oh, we're lucky here, right? We get. All right. So now, so the integral becomes is going to be the denominator here is just square root. Dx over e to the x is nothing but just negative du. Great. Yeah. I should write the integral symbol a little bit high. Yeah, so that's it. So there's no denominator because x over e to the x, dx over e to the x is just du. Okay. So now you can find the antiderivative u to the 1/2 du. This is very natural. It's going to be 1/2 plus 1 u to the negative equal 1/2 plus 1 and plus constant. Right? Let's simplify it. Okay, it's going to be negative 3 over 2 u to the 3 over 2 plus constant. So what is u? U is 1 plus e to the x. So it's going to be negative 3 over 2, 1 plus e to the negative x. So that's okay, this is just the n, just indefinite integral, the antiderivative of the function. So the integral from 0 to 1, you have to evaluate. Okay, its value must be positive. Be careful, because the function itself is positive. The integral of the function should be positive. So when you do the simplification, evaluate 0, right? So this should be positive. The first number is going to be 1 plus e to the negative 1, 3 over 2, minus, so it's negative, right? It's positive then. 1 plus e to the 0, 3 over 2. Right? So this must be positive. Two-thirds. Oh, yeah, 2/3. That's right. Yeah, that's it. Change it. Yeah, 2/3. 2/3. You're right. I still remember I got a 90. I think I got 98 when I was an undergraduate certificate. I lost a couple points just because this kind of error. 2/3, 1/3, yeah. Okay. So this is the answer. You know, I tried to simplify a little bit because the second one is just a 1. So, you know, put the positive one on first. Minus 2/3. Okay. And nothing we can do with for this one. But this is going to be positive. Hold on. It's not going to be positive now. Oh, this is 1. Yes, 2. Yes. This will be positive because the first 2 is larger than 1 plus e to the negative 1. Okay. Why is 2, not 1? Because the 1 plus e to the 0. E to the 0 is 1. So 1 plus 1 is 2. Okay. So this is going to be positive number. So here's f of x equals 4 plus x, then x e to the x. Find the derivative of the function. Now, what is the best way to find the derivative of this function? I think the best way to find this derivative, don't use a quotient, okay? Avoid to use a quotient, it's even more complicated. And if possible, avoid to use a product rule, okay? Because you're always splitting the 2 terms. Okay, so I'm going to modify this function and I will get 4 divided by x times e to the x. So it's a 4x to the negative 1, e to the negative x. And the second term is the x is gone, just e to the negative x. So I have to apply the product rule to the first term. All right. So I'm going to find the derivative. So 4 times the derivative of x to negative 1 is negative x to negative 2. Then I differentiate e to the negative x is going to be e to the negative x times negative 1. Then the same here. Okay, so you get negative 1. Then you simplify a little bit. You can take that as a common term there. You can take it out if you want. It's negative 4x to the negative 2 e to the negative x is negative 4x to the negative 1 e to the negative x and negative 1 e to the negative x. Okay, that's it. You know, this is nice one. We don't need to worry about. Okay. If you have to find the critical numbers, then you have to take the common factor out and try to solve the quadratic equation. Okay. Otherwise, just leave like that. Yeah. E to the x is it's indeed an interesting function. So let's look at the y equals e to the kx. So y prime equals e to the kx times k, right? So e to the kx still can be replaced by y. So if there's some quantity, it depends on, it's some quantity. I even put a more general, I put the a naught here. So there was a constant here, okay? So leave that. Then this part is still replaced by y. So that means y prime equals y equals k, okay? So if y is going to be y naught plus times e to the kx, then the derivative of y equals k. So the derivative is proportional. So that means the rate of change in y is proportional to y. Okay? There are many, and conversely, if you get something like that, you can go back. This is a back forward, okay? If the rate of change in some quantity is proportional to the quantity, then that quantity must be expressed as this power function, okay? Exponential function, yeah. The converse, if some quantity is expressed by exponential function, then you must have this y prime equals k times 1. There are many phenomena. Well, we can describe using this equation. For example, you have a bunch of bacteria in the container. The growth of the bacteria obeys this rule. So the rate of change in the quantity of bacteria is going to be proportional to the quantity of bacteria. So more bacteria grows much faster. Okay, of course, the container is limited. At a certain age, we're crowded. Look at us, like our population, human being population. Okay, if the weather is nice, no war, no nuclear war, okay, no disease, and there's a reproduction, natural reproduction is to be the population grows naturally until the resource is not enough resource. Okay, then the growth rate must slow down. Okay, so we don't know, right? So right now still the population grows, but the proportional to, and for any period of time, it's still almost proportional to the size of population, but the constant k changes from time to time. Right. So I stop here, and